Yes, dear students, we have already taken the theory part of this particular experiment, no load and block rotor test, in our introductory part. In the second part of this experiment, we will learn about the procedure and then how to perform this particular experiment. So first of all, we explain the different parts, different apparatus used in this particular experiment. So we have this is the induction motor panels. This panels is basically designed for two types of motor, spiral cage induction motor and slip ring induction motor. So this is the spiral cage induction motor which fitted here on this platform, and this one is the slip ring induction motor in this platform. And connections have to taken on this board. See that this one is the spiral cage induction motor. There are 6 terminals here. 6 terminals means by connecting these terminals you may connect in star or delta fashion. And this in this circuit diagram, this is the connections is connected in delta fashion. Similarly, this connection is given for the slip ring induction motor. So we have to perform no load and block rotor test on this spiral cage induction motor. So this is the panels. In these panels, the different ranges of ammeters and voltmeters are given here. MCB switch given here, and it's a circuit diagram is given here. This circuit diagram symbols for 3-phase varied. 3-phase varied instrument. This is the auto transformer or 3-phase varied, and this is the multifunction meter. Multifunction meter means why it is called multifunction means you can measure all the electrical quantity like current, voltage, power factor, power, reactive power, frequency, line-to-line voltage, everything you can measure with the help of this multifunction meter. That's why it is called multifunctions. So this is the RPM, means spiral cage and slip ring. 2 RPM indicator are given here. It can measure the speed of spiral cage induction motor, and it will measure the speed of slip ring induction motor. So first of all, we will try to connect the circuit as we have already told in the circuit diagram in our introductory part of this experiment. So this C1, this is the auto transformer, and we will take connecting leads here. So this is the input terminals. As you know, the input is the constant 415 volts, and this is the output terminals. This output terminals will connect. Output means variable outputs will connect according to this diagram. See that this is the auto transformer terminals. These terminals, there are 3 line terminals, 1, 2, 3. In these 3 lines, the 3 ammeter are connected in series, and this terminals is going to the 3 spiral cage induction motor. So first of all, we connect this portion of the circuit, and this one is the ammeter here in series like this. The main precautions while we connect the circuit, the connections must be tight for safety point of view. And second, ammeter connect here. Ammeter connect here, second terminals. And third, A3 terminals. A3 terminals. So these are connect series. The second part of ammeter, see that it is going to the rotor terminals, stator terminals. This is connected spiral cage induction motor star connection. We will connect the star connection. You will also connect delta, but we will connect the star connection. How to connect the star connection? You know, in a star means similar points are connected either to starting or finishing. So see that this is the 6 terminals A1, B1, A1, A2, B1, B2, C1, C2. There are 6 terminals. Depending upon the connections, you may connect in star delta. So we are considering only star fashion. Clear? And how to connect in star? In a star fashion, so you have to create a neutral point to star point. In star points, see that this is the same connections here. So these are common points or neutral points like this. These terminals connect here and this one here. So it is the neutral point. neutral points. Okay, and now suppose you have to connect in delta. Delta is nothing, just to avoid delta connection like this: A1, B1, B1, C2, and C1, A2. This is the delta connection. In the delta connections, you know, there is no neutral points. So you may connect in star delta, but in this experiment we are considering the star connection. And the star connection, we have to create a neutral point. Neutral point. The neutral points is a common terminals. So this is the star connection. Now, from this output terminals here, a multifunction meter is not connected here. But we can connect a multifunction meter. Then how to connect the multifunction meter? Multifunction meter means the output second terminals of a meter A2 terminals and A3 terminals. Actually, this multifunction is not showing in this diagram. You may connect the multifunction meter. Input terminals RYB, red, yellow, and blue. RY means red, yellow, blue. It's the symbols of phase sequence. Symbols of phase sequence. Connection should be tight. And this output terminals of this multifunction meter connect in the stator terminals of E1, and bias connect to B1 and P's connect to C1. So a multifunction meter attached on those positions. The multifunction means it will measure input, no load input power and no load power factor. And these are A1, A2, A3. These are connected in lines. So it will measure line current. And second thing, we have to connect a voltmeter here. So we voltmeter connect across two lines for measuring line to line voltage. Line to line voltage means you will connect in these positions. There are two lines, A1 and A2, V1. So we have to connect V1 terminals. In that case, we have to observe the readings of A1, A2, A3, A1, A2, A3 for determining the line current, and V1 voltmeter for measuring the voltage. So this is the complete circuits for performing the no load test. Second steps, after doing the connections, what we have to do, we will perform no load. No load means no any load is connected on this pulley. Means just this pulley we have to allow free to rotate. No any mechanical load is applying here. That's why it is called the no load position. No load condition, it means see that then zero positions means no any mechanical load is applied here, and it is called as no load position. Second, we have already studied in the theory part of this experiment. This test is performed at rated voltage. The rated voltage of this machine is 415 volts and speed is rated speed 1500 RPM. So with the help of auto transformer, firstly you have to increase the voltage up to 450. Second thing, the main precautions, remember that while you perform this experiment, in any experiment, not like this, auto transformer should keep at zero position. It will keep at zero position. Otherwise, suppose it will like this here, and you will just start, and suppose the connection is wrong. In that case, the high voltage will go in this machine and all the meter voltmeter may be damaged. So this is the main precautions when you perform any experiment in electrical engineering with the help of auto transformer. This auto transformer is kept at zero positions. Now apply. What is the apply? Switch on the MCB, and with the help of auto, gradually increase the voltage up to 415 volts. So we start the switch. So we start the switch, and deflections in given all the meter. In that case, we have to measure A1, A2, A3 and B1 and the multifunction meter. So gradually increase the voltage and see the deflection of V1 voltmeter. See that 38, 47. As we are increasing the voltage, the motor is moving. I think speed is in that conditions is speed is 370, so 500, and A1, A2, A3 indicates the line current. See that all the current are approximately equal. It means system is balanced. System is balanced, and this voltage value 238, 248, the speed is increasing, 292, 315, 354, 380. Yes, this is the rated value, 410, 411. This is the rated value of this voltage. At this voltage, we will take the readings 0.9, 0.7, 0.7, and this is a multifunction meter. This multifunction meter measures the wattage. There are 3 wattage, and suppose you have to take its power factor. The power factor means with the watt, power factor is 0.19, 0.19, 0.3, it's the value of power factor. So we will take by the readings of power factor, power, line current, voltage. With the help of these readings, you may determine its performance of this spiral induction motor with the help of power circuit test. So this is the no-load test, and this multifunction meter measures the power in each phase. 1, 44, 19, 67, and by adding all these phase power, the power reading you will measure, normal input power. So with the help of these readings, you will draw its power circle diagram. So this is the no-load test. Here, now doing the second test means like the block rotor test. In the block rotor test, firstly we will reduce the voltage. We will reduce the voltage and bring the auto transformer knob at 0 position, and the speed is gradually slow. See that the speed is decreasing because we have to reduce the voltage, and current is 0. Voltage also down. And the rotor eventually stops and then switch off. And wait up to for a stopping time of this motor, and then we will perform the second part of this test, block rotor test. So yes, the second part of this experiment, block rotor test. Block rotor test means head is clear from its null, rotor is blocked. Rotor is blocked means it will not rotate. We have to tie it with the help of this pulley. Then how to block it? With the help of this mechanical load, tighten the belt in such a way the rotor, this motor will not move. Tightly tight. See that it is not rotating. It means it is blocked. That's why it is called the block rotor test. Second thing, it is blocked, and it's a load is here. See that is not 0 positions. It is 22 kg here and 21. So it is totally blocked. Second thing, we have already learned in this theory part, this test is performed at the rated current. The rated current of this particular machine is 5 ampere. The 5 ampere is given its nameplate rating of this machine. The machine rating is 5 HP, 5 ampere and 450. This test is performed at the rated current. The rated current means with the help of auto, gradually increase the voltage up to 5 ampere current. The 5 ampere current is recorded from this A1, A2 and A3. So this is the conditions for block rotor test. This test performed at the rated current. So no load test rated voltage and the block rotor test rated current. And supply on, switch on, switch on, and the process is the same, but the main provisions is that the current should not increase by this rated value, means up to 5 ampere. 5 ampere means readings 1.4, 1.9, 3.5. Yes, this is the rated current. 4.7, it's a rated current. 4.4.4 and the short circuit voltage V1, V2, V1 only here, and it's a power. The power is high as compared to no load. 328, 302, 362. By adding all this power, we can calculate short circuit or block rotor test power. So this is the readings for block rotor test. It means in that test you have to set its rated current. In the no load test we have to set load current. By all these readings and for gradually reduce the current and up to 0 ampere. So this is the readings for block rotor test by and motor load is reducing. It is comes at 2 positions. Means it is free, and with the help of this short circuit current or block rotor current, power and voltage of this block rotor test and from no load test, we can measure its efficiency, its performance of the machine with the help of circuit diagram, and that calculation parts we will learn in the next part of this particular experiment. Thank you.
Hope you all have understood the experiment. So what is the conclusion from the experiment? Here you will write all the parameters which we have find in the which we have discussed in the earlier part of theory part of the video. You will take the readings and find the parameters and write down here. And you should also be able to answer these discussion questions. So note down these questions and you should answer this question while writing the journal. Thank you everyone.